Hello and welcome to today's class. We're still on first method of differentiation. Let's consider example 4, right? But basically, example 4 will be different from what we have been doing in example 1, 2, and 3. For example 4 there, we'll be considering rational numbers, right? So let's say example 4, right? Example 4, let's say I have y to be equal to 1 over x, in this case in fractional form. How do you find the y over the x here? Using first principle method of differentiation. The task is quite simple. What we know before now is that when it comes to first principle, the key word there is that to y had change in y, and then to x had change in x. That's like the key concept to note there. But if I do this using first principle, let's try using general method and let's see if our answer will be comparable. So let's get this done, please. Let's say I have that y is equal to 1 over x. I want to solve this man using our normal first method called general method. At this point, at this level, at this stage under this topic, if you don't understand the general method, I would advise to go back to the first video on differentiation, which is known as general method. So try to watch the video, right? That's the basic per se. That's the basic. So try to watch that video, understand it first before you dive into all these concepts here. All right. So I'll drop a link to our first class on differentiation called general method, right, in the description of this video. So try to check the video. You'll see a link there. Let's try to solve this one using first general method per se before you use first principle. From here, we said in this case, I can apply our normal concept here that says that multiply by the power and subtract from the power. In this case here, there's nothing like power here, right? So I'll try to express the question in terms of something that will have a power. What's the idea there? This becomes y is equal to, if I take this one to indices, I should have x to power minus 1. In indices, if I have a raised to power minus 1, it can be expressed as what? 1 over a. So observe, I'm having 1 over a. Similarly, 1 over x. Take it as what? As this, applying the concept of indices. So I have this now. So it's now become something I can solve using general method now. So what's the concept? Said multiply the power. So of course, I'm having y and x. I shall have the y over the x to be equal to, what's the power here? Minus 1 times, everything here becomes x to power minus 1, also minus 1, right? From general method. Please try to watch the video, right? You should know this now. Minus 1 remains the same, right? Times x to power what? Minus 2. Minus 1 minus 1 will give minus 2. From here, I will have minus 1 times, I'm having a raised to power minus 1 because 1 over a. I'm having x to the power minus 2 because of the 1 over what? X squared. Applying what the indices. From here, I'll have minus 1 times 1 is what? Minus 1 over what? X squared. So if I differentiate y to be equal to 1 over x, my dy over the x, dy over the x is equal to what? Minus 1 over x squared using general method. Let's now apply first principle and let's see if our answer will be comparable, right? So first principle there, the task is quite easy. We said to this y had change in y is equal to 1 over, this is x, of course, had change in x, as in this case. Next procedure is take this y to the other side. I'll have this man change in y equal to 1 over x plus change in x minus this y becomes what? A minus y. At this junction, my next task is to say that but y in the question is what? 1 over x. 1 over x. So anywhere I see y, I'll put 1 over x there. That's the meaning. For me, I'll have change in y is equal to 1 over x plus change in x minus, what is y? 1 over x. So I have 1 over x. In mathematics per se, let me just encase in brackets, right? In mathematics, if I have two fractions and I'm having either plus or minus in the center, what comes to mind? LCM. That's the concept in mathematics. If I have two fractions this way and I'm having either plus or minus in the center, what comes to mind? LCM. But if I have times there, you don't apply LCM. You break them down or you multiply them. But for this case where I have minus, what comes to mind? LCM. So I'll look for my what? Applying LCM concept. For me, I'll have that change in y is equal to, if I have, observe that, what's my LCM? If I may ask you, what's my LCM here? Take a little bit and think. What do you think my LCM here will be? Think, what will be the LCM here? If I may ask you. In this case here, my LCM is not x. My LCM is not in x. Rather, my LCM is x into expression in x. So this term here is assumed as something else. X2 is under something else. So if two uncommon term, if you're looking for the LCM of two uncommon term, the two term becomes the LCM. So these two are not the same, are not common. So the 2 becomes the LCM. So I'd rather start with x first. My LCM becomes start with x into what? X plus change in x. This 2 becomes your LCM. Let's start with this first one here. If this one here, this one divide this one, I'll be having only x left. Now this x here times 1 is of course x. So I have x. This is minus sign here. Similarly, this x can cancel this x. I'm having this one left. This same value here times 1 times this one will give what? X plus change in x. Mind you, I encase my answer in a bracket. Very important place. Don't just write x plus in x this way. It means something else. Rather, encase it in what? In a bracket. At this junction, I'll have that change in y is equal to x minus times x. Expand the bracket. Minus times x, of course, minus x. Minus times plus is what? Minus. I have change in x here. So all over, what next here? Repeat the denominator. So I have x into x plus change in x. So I have this. Alright, from here, if I simplify very well, this man should cancel this because I have plus 1 minus 1, it's 0. Similarly, plus x minus x is 0. So I'll have minus x left as my value for the numerator. From here, I'll have that change in y is equal to minus change in x all over x into x plus change in x. At this point, check your previous example in our previous video. After cancelling out an expression or an expression has been cancelled out, what comes to the next task is to divide through by change in x, right? So divide by change in x. So I shall have change in y over change in x to be equal to minus change in x all over x into x plus change in x. We said what? Divide both sides. Divided by change in x. So I have this. So we're dividing both sides by change in x. So I have this. Right? So let's proceed with this. And let's see what we get. Mind you, don't forget that I'm after getting this answer. So I'll not rub it off. I'll not clean it off. I'll not clean it. So I'll leave it pending. And mind you also, we said the y over the x is same thing as what? Change in y over change in x. That's the concept. Alright, from here now, I'll have these two expressions. Change in y over change in x is equal to, this one here becomes minus change in x all over x into x plus change in x. Right, this one here, divided can convert to what? Times. I'll convert division to times. So there's an invisible one here, right? This one comes up first, all over, this one comes down. In fraction, to change division to times is easy. This division becomes times here. Just do a swapping, right? A reciprocal concept, just swap it. This down here comes up first, this up one comes down, then you apply your times concept. From here, this will cancel this by mathematical approach. From here, I'll have that. Hold on guys a little bit. Let me tell you what you need to know. Actually, I'm running a membership program, right, which can help you a lot. So to join my channel membership, it's quite easy task, right? As you can see, the icon I'm showing you here, that icon is my membership opportunities, which you can access monthly. So I'll drop the link to the membership in the description of this video, right? So just click there, click on the membership link, so you purchase the one you want. So I have for JAMB and WAEC classes, and also I have for 100 level students. So whichever one suits you, click there and subscribe. If you, perhaps click there and purchase the one of your choice. Anyone you purchase, there are several advantage videos that I will not allow people to see. So it's for only those who have joined the channel that will have access to those even advanced problems. And also, I do help students from different countries to solve their assignments. So if you're in UK or abroad or Canada or anywhere you are in the world and you want me to help you do your assignments, you can simply check me. You can simply visit me on my WhatsApp number, or also share this video. I'll drop a link to a website there. In the website, you can register with us and you let us know which assignment you want us to help you to do. Do well to join the channel. Thank you. You can proceed with your learning now. Change in y over change in x now is equal to -1, right? There'll be 1 here left, all over x into x plus change in x times, this is 1 over 1, of course, that will give 1 over 1, because if this divide this, there will be 1 here, 1 here. So multiply this through, I'll have change in y over change in x is equal to -1 times 1 is of course -1, all over what? X into x plus change in x. And we said initially from our previous classes on first principle method, in our previous examples, we said after dividing through by change in x, and you are still left with the change in x, take the limit of that in x to be 0. So I'm saying that take change in x to be what? 0. What do I have? Change in y over change in x is equal to -1 all over what? X into x plus, this becomes 0. Mind you, my answer that I'm trying to get is given as, let me write it here. The answer is -1 over x squared. That's my plan, right? So let me just wrap it up for space sake. If I put change in x at 0 here, what do I have left? Therefore, change in y between x is equal to -1 all over x. Observe x. Observe that I have a bracket here. 0 is nothing because what? A bracket x this way, right? A bracket x, and we know that this means s times x. Of course, s times x will give what? S squared. So to save time, just put x squared. So observe that the answer I had when I solved 1 over x using first principle becomes what? -1 over x squared. Similarly, when I use first principle, I have -1 over x squared, as you can see in front of you. This has solved a problem using the rational variables, right? As you can see how we solve this exact problem. Let's do yet one more example under first principle. I'll look at several other more methods called the chain rule method of differentiation.